Our next competitor is Anastasia Sarmakeeva. Anastasia is a doctoral student in a CEES program in mechanical and aerospace engineering. Anastasia's presentation is entitled Landslide Simulations to Save Lives. Anastasia.
Landslides claim almost 5,000 lives every year. Did you know that? Sounds shocking, right? Only in the US, it causes in excess 1 billion in damages. The majority of these events happens along the coast, where soil, boulders and rocks often fall into the water. But there is hope. We can use computer simulations. Initially, these predictions weren't good. But today, with using network of computers called supercomputer, we can make accurate forecasts. To make predictions of such a complicated and dangerous process, we need to divide the area where we want to make predictions, landscape, into small tiny pieces and solve at least 10 differential equations at each time step. Then I collect the results and solving the same equations for new variables, and doing that over and over again. So with that way, I know how my landslide is moving, with the velocity of the landslide, at what speed, the area which is going to be covering. I also know if the water level will rise when the stones and mud will fall into the water. So to make predictions, I need to solve at least 10 equations at each piece, at each time step. Sounds cumbersome, right? We have in mind that we're solving our equations for a landscape. If the flow behaves like a liquid, we can use fluid simulation methods. But it's not just mud flow. If the flow includes boulders, stones, rocks, the cells could cover up to half a third of the cell. The density parameter won't be even. So what can we do? We need to think outside of the box. Stones, rocks, boulders remind us granular media. I suggest to use granular media for simulations. In my work, I use cutting-edge methods for water simulation, and the best approach to do granular media movement and interactions. With the help of supercomputer, we can make accurate forecasts by solving huge system of equations, predict this kind of natural disaster, and potentially save many lives.
Thank you, Anastasia.